Now we begin a new topic, triggers in PL/SQL. Triggers are special database objects that are automatically executed in response to specific events such as insert, update, or delete operations. In this lecture, we will learn how to create, use, and manage triggers and understand their role in enforcing business rules and maintaining data integrity. This slide outlines the learning objectives for the topic of database triggers. By the end of this lesson, you will understand what triggers are and how they are used in database systems. You will also learn about the different types of triggers depending on when and how they are executed. In addition, you will be able to create triggers, understand the rules that control when triggers are fired, and manage them effectively, including how to remove triggers when they are no longer needed. Finally, you will learn how to view and analyze trigger information using database tools. Overall, this lesson will help you understand how triggers can be used to automate processes and enforce business rules in a database. This slide explains the concept of triggers in PL/SQL. A trigger is a stored PL/SQL block that is automatically executed when a specific event occurs in the database. Unlike procedures or functions, triggers are not called explicitly by the user. They are fired automatically by the database system. These events can include operations such as insert, update, or delete, or other database actions. When the defined condition is met, Oracle automatically executes the trigger. Triggers are commonly used to enforce business rules, maintain data integrity, and automate tasks without requiring manual intervention. Overall, triggers play an important role in making database systems more responsive and self-regulating. Triggers can be defined at various levels: table, view, schema, or database. A table-level trigger responds to changes in a specific table, while a view-level trigger operates on a view. Schema-level triggers apply to all objects within a schema, and database-level triggers affect all users and operations across the entire database. Triggers can be set to activate on various database events. These include data manipulation language statements like delete, insert, or update, data definition language statements such as create, alter, or drop, and operations like server, error, logon, logoff, startup, or shutdown. Understanding these events is crucial for effective database management. This slide distinguishes between application triggers and database triggers. A database trigger, which is the focus of this course, is executed automatically when events occur within the database, such as DML operations, insert, update, delete, DDL statements, or system events. These triggers operate at the database level and are used to enforce rules and maintain consistency. In contrast, an application trigger is executed within a specific application when certain events occur, such as user actions or interface events. These are managed by the application logic rather than the database. The key difference is that database triggers are controlled by the database system, while application triggers are controlled by the application layer. Overall, database triggers provide a more centralized and reliable way to enforce rules directly within the database. Triggers in business applications enhance security by enforcing access controls, audit changes for compliance, and maintain data integrity by validating inputs. They ensure referential integrity by managing foreign keys, replicate tables for redundancy, compute derived data automatically for efficiency, and log events for monitoring purposes. This slide presents the main types of triggers available in Oracle. First, we have simple DML triggers, which are fired in response to data manipulation operations such as insert, update, and delete. These can be defined as before or after the event occurs. The instead of triggers are typically used with views and allow you to define custom behavior instead of the standard DML operation. Next, compound triggers combine multiple timing points into a single trigger, which helps improve performance and manage complex logic. Finally, there are non-DML triggers, including DDL triggers that respond to schema changes, and database event triggers, which respond to events at the database level. Overall, these trigger types provide flexibility in handling different kinds of events within the database. Trigger event types dictate which data manipulation language statement activates the trigger: insert, update, or delete. The trigger body specifies the action executed, either as a procedural language structured query language block or a call to a procedure. Understanding these components is crucial for effective trigger implementation. To create a data manipulation language trigger, use the create trigger statement. Specify the trigger name, timing, and events like insert, delete, or update. Define the object name and optionally reference old or new values. The trigger body contains executable statements and you can handle exceptions. Timing options include before, after, or instead of. Specify trigger timing to control when the trigger's action occurs. Use before to execute the trigger body before the DML, data manipulation language, event on a table, after to execute it after the event, and instead of to replace the triggering statement, particularly useful for non-modifiable views. Statement-level triggers execute once per triggering event, regardless of the number of rows affected. In contrast, row-level triggers require the for each row clause and execute for each affected row. Notably, statement-level triggers fire even if no rows are affected, whereas row-level triggers do not activate if no rows are impacted. Testing the secure ArchEMP trigger involves inserting a new employee record. Attempting to insert Rob Smith into the employees table with ID 300 during restricted hours will raise an error. This ensures data modifications occur only during business hours, maintaining data integrity and security. The trigger SecureEMP restricts data modifications on the employees table outside business hours. It raises specific errors for unauthorized actions, 2502 for deletions, 2500 for insertions, 2503 for salary updates, and 2504 for other updates. This ensures data integrity by enforcing time-based access control. OLD and new qualifiers in triggers allow tracking of data changes. OLD stores original values, while new holds updated ones. For insert operations, OLD is null and new contains the inserted value. During update, OLD has the pre-update value and new the post-update value. Delete operations leave new as null, with old storing the deleted value. The trigger auditEMP values captures changes in the employees table. It logs user actions, timestamps, and both old and new values for last names, job IDs, and salaries. This ensures a comprehensive audit trail by utilizing the OLD and new qualifiers to track data modifications effectively. Instead of triggers are crucial for handling data manipulation language operations on complex views. When an insert or update is attempted on a view like MyView, the instead of trigger intercepts the operation, allowing custom logic to execute. This ensures data integrity across underlying tables, such as Table 1 and Table 2, by redirecting operations appropriately. Creating an instead of trigger allows data manipulation language operations on complex views like EMP2Details. This view aggregates employee and department data, grouping by department. The trigger facilitates updates by redirecting changes to underlying tables' new EMPs and new DEPs, ensuring data integrity while maintaining the view's complex structure. A trigger can be either enabled or disabled. When enabled, it executes its action if the triggering statement is issued and any restrictions evaluate to true. Conversely, a disabled trigger will not execute its action regardless of the triggering statement or restriction evaluation. This slide explains how to manage triggers using SQL statements. You can use the alter trigger statement to enable or disable a specific trigger, depending on whether you want it to execute or not. Similarly, you can enable or disable all triggers on a table using the alter table statement. If a trigger becomes invalid, you can use the compile option to recompile it and restore its functionality. Finally, if a trigger is no longer needed, it can be permanently removed using the drop trigger statement. Overall, these commands provide flexibility in controlling, maintaining, and managing triggers within the database. Testing triggers involves verifying each triggering and non-triggering data operation. Evaluate each scenario in the when clause. Ensure the trigger fires directly from data operations and indirectly via procedures. Assess the trigger's impact on other triggers and vice versa to ensure seamless database functionality. Access trigger details through data dictionary views. User objects shows object information, while user all DBA triggers provides specific trigger details. For PL/SQL syntax errors in triggers, consult user errors. These views are essential for managing and troubleshooting database triggers effectively. In conclusion, in this lesson we explored the concept of database triggers and their practical use. You have learned how to create triggers that respond to DML operations, as well as the difference between statement level and row level triggers. We also discussed the rules that control when triggers are fired and how to properly use them. In addition, you now understand how to manage triggers, including enabling, disabling, recompiling, and removing them when necessary. We also highlighted the importance of testing triggers to ensure correct behavior. Overall, triggers are a powerful mechanism for automating processes, enforcing business rules, and maintaining data integrity within the database.